All right, so we're going to look at the properties of graphs with quadratics today. Remember, they all make the shape of a parabola. So what I'm going to do is I'm going to just sketch one here for you to see it, and then we'll talk about it a little bit. So this here is a parabola. I only drew the first quadrant, but technically, like, it could come back like this and keep going. But we're not going to really worry about that. Okay, so I'll put down a few points. Let's say my y-intercept is at 0 and 2. Let's say that this is at 1 and 3. This one here is at 3 and 3. Cool. And this one here is at 5 and 0. Okay. Is everyone cool with that? Okay, so with this graph, let's talk about it a little bit. Is it opening upwards or downwards? Yeah, sorry, down. Okay, downwards. So we know that my A value is negative. My y-intercept which is my C value, is yeah, it's at 2. Good. Where it crosses the y-axis. Oh, someone's blowing up over here. Well, you can also see, do we see where one of the x-intercepts are? Or where the x-intercept is? 5, right? Now, is that anything to do with this equation? No, but it's still something we know. And, equals 5. Okay. Now, just so we kind of get used to some of the terminology, sometimes the x-intercepts are also known as the zeros. Okay, because it's where x, or it's where y is 0. Okay, so sometimes we refer to them as zeros of an equation. But we'll get more into that a little later on, just kind of introducing some terminology here. Now, another point that we talked about yesterday that we haven't come across here yet is the vertex. Right? Where is the vertex on this graph? The very top of it, right? Very good. My vertex is right there. Okay? Remember, now with this graph, because it opens downwards, is my vertex going to be a maximum point or a minimum point? Max, right? This is the highest point on the graph. So we could say it's a maximum. Now, do you guys remember what we called the line that came straight down through the vertex and cut the graph exactly in half? Something symmetry. Very good. I'll take that as a pretty good win, actually. Your axis of symmetry, right? And cuts the graph. That should have went through the vertex. That should be all straight. Symmetry. Okay. So we know it cuts the graph exactly in half. So could you guys tell me, maybe not the y coordinate, but could you tell me what my x coordinate is here? for my axis of symmetry. Like, where is this x value? It's not 3. It's going to be just 2, actually. Just the x coordinate. Because remember, it's going to be the same distance from here as it is from here, right? And so it's going to be halfway. What's halfway between 3 and 1? 2, right? Another way you could do it, you could do like find the average. You just go, you take your one x point plus your other x point, which was 1, and you divide it by 2. It just cuts them in half. You can only do that, though, to x values where the y value is the exact same. Okay? Does that make sense? Yeah? Everyone's okay? Owen? Never told you, man. Stone-faced son of a gun. All right. Cool. Let's try another example here. Compare. Let's try one here. All right, so we're going to sketch a graph for the following quadratic now. Okay, so that means I'm going to give you an equation, and we're going to come up with what it looks like-ish. Oh, but we also want to find x and y intercepts. Vertex, and if you guys remember this, domain and range. Those words sound familiar? Okay, we'll go over them in a minute. I'm not expecting you guys to remember what those are totally, so we'll brush up on them.
X and Y.
Yeah, very good. Okay, never mind. Should have given you guys a little more credit. Yeah, your domain is all your x values, and your range is all your y values. We'll go over this. It's a little bit different than what we did with linear equations, but it's still pretty straightforward. Okay? So, here's the equation that we're going to use. I believe it's just x squared plus x. Minus 2. Okay, so just looking at this, we know our graph is going to open which direction? Yeah, upwards. So that means our vertex is going to be a minimum. We can see that the y-intercept is at -2. So we're kind of on a roll here. So when you got to sketch these things, what I always recommend doing is I just take 3 or 4 values just to get a general idea, and then I sketch it from there. Okay? So I always set it up kind of like this. Do a table of values, x and y. And 4 values is typically the easiest to do. I usually start at, because my y-intercept's at -2, I'll usually go 1 past that. So I would do like -3, -2, 0, 1. Oh yeah, -1. Thanks, Chloe. -2, -1, 0, and 1. Okay. I always kind of use these smaller numbers because I'm going to plug each one into the equation to see what I get. So the smaller the numbers you use, typically the easier it goes. Sometimes the textbook will give you harder ones to use, but it's no big deal. So for the first one, I'm just showing my work for the first couple. It's going to be -3 squared -3 -2. What's any, whenever I square a negative number, what does that become? Positive, right? Even though your calculator is going to say it's -9, we all know it's actually 9. Okay, calculator just read it wrong. -3 -2. My y value is 4. Okay. Put in -2, so it's going to be 4, take away 2, take away 2, 0. Do I need to show all my work for these? Do you guys kind of understand what I'm doing? Is that what was that? Yes or no? Do you want to see me to show? Okay, no problem. So it's -2 squared -2 -2. 4 -2 -2. What's 4 take away 2? What's 2 take away 2? Okay. Well, okay, so -2 squared, right? Because that's the value I'm plugging in, right? Plus x, so it's going to be plus -2. What's a positive and a negative make? No, negative. So it's like that. Oh, there's a -2 there. Because it's right there.
It's just 2.
Yeah. Okay. Then I put -1 in. So it's going to be -1 squared, take away 1, -2.
Okay, wait, so you just take it away by itself and then you take away the solution?
Yeah, I work out the question. So -1 squared is 1 minus 1 minus 2. So that works out to be -2. Now I'm not going to put 0 in and show you guys that work. If x is 0, what's my y value? Right? That's the y-intercept. Is that right? Oh, I see why. Okay, that'll work. And then if I put 1 in, it's going to be 1 squared plus 1 minus 2. 1 plus 1 is? 2 take away 2 is? Okay, so those are my values. What, Chloe? Say it now. Don't ask me 10 minutes from now when I'm moved on and you're still confused. All right, so that was a tired pen throw, not a I don't know what I'm doing pen throw? Okay, for the record, it's on video. Chloe says she's following along. All right, now we'll graph this. I think I can get away with going up by 1. Oh. Okay? How are we all feeling so far?
It's a little
Where are you getting confused? Let me know.
funny.
Here?
Well, like, it's not like hard, just like, I guess it's a lot to remember.
Just new. Okay, you're just taking the numbers and plugging them in right now. Okay? And I'm just kidding. Like, I picked these points to work with. Those I chose because they're small numbers, easy to work with. I then plug each one into the equation here. All right? By doing that, these are the answers I get. These are my x values. The answer I get is my y coordinate. Okay, so now I just plot those points. So for the first one, when x is minus 3, what's my y value?
What?
When x, so we're going to plot the first one. When x is minus 3, what's my y coordinate? 4. Yeah. Well, for this graph, I'll explain more after I'm done graphing. Somewhere like there, okay? Maybe I'll use a different color. Yeah. Yeah. Right. Now when x is minus 2, what's my y coordinate? So that's right here. When x is negative 1, what's my y coordinate?
It's negative.
Right.
Or,
That's okay. When x is 0, what's my y coordinate? Negative what? Okay, I thought I heard a negative 5. I'm like, what? Okay. Now, when x is 1, is that the last one we did? Okay, that's fine. So now I can make a sketch of the graph. Okay? So my graph does something. Yeah. And it keeps going. And it did something like this. It's going to keep going there. I just took 4 points. In theory, this graph goes on forever. That's why the arrows are there. All right. Questions? Who's got them? I know I'm a good parabola drawer, but I don't know if I'm good enough to go through all that and not have any questions. Well, we drew it. It's done. But now we can answer questions about it. Right? What did I say these shapes are? They're just either the U or the N.
When you got your points, you just like draw to that point. And
I kept going because technically this graph goes on forever. Okay?
so like you don't stop at the point.
You could just draw it a little past and then put an arrow on it. Because that arrow then means it's still going. Okay? I'm just sketching it based on these 5 numbers, the 5 easiest numbers that I could think of. Okay? That's all. But the graph technically keeps going. Just like when we drew, remember when we did linear graphs? You drew like arrows on the end? That just meant it kept going. All right? All right, now we can finish this off. So first thing the question asked for was the intercepts, right? So the y-intercept my y-intercept is where? Well, we would say the coordinate would actually be 0, -2. Okay? Yes, I know.
So you can't put -2.
You could for the y-intercept, but for the x-intercepts, I want coordinates. Thanks for the eye roll, Chloe. X-intercepts. Where does the graph cross the y or the x-axis?
0.
1 and 0. Very good. Is there another place that it happens too?
So -2.
-2 and 0. With parabolas, it's possible to have up to 2 x-intercepts. Can't have 3. You could have 0, 1, or 2. How do you get 1?
No. I was going to say how do you get 0, but no.
If your graph is like this. Okay. All right, now the vertex. The vertex is somewhere here, right?
I'd say it's a negative 2.
It's going to be, I think, slightly lower than negative 2. Do you get
What?
the x value is 1.5.
What are we looking for?
The vertex. Do you guys remember how we did the vertex last time? Remember?
Oh, they had the same one.
Yeah, as long as they have the same y value, we take the average between 2 points. Because remember, it's going to be, let's use this one here. Okay, negative 2. We know we have 2 y values that are the same here, right? All right, negative 2, negative 2. So we just find the average between the 2 x values. So we use these guys here. So my vertex is going to be the average between negative 1 and 0.
1.
Well, negative 1 take away 0 is
1.
negative 1.
Negative 1, yes.
Negative 1 plus 0.
Yeah.
All right.
Let's do that.
Negative 1 divided by 2, you could either leave it as negative a half, or nobody likes fractions anymore, so we can write it as negative 0.5. All right. So right here between negative 1 and 0, negative 0.5.
Negative 1.
No, negative 0.5. Now, what if I wanted, like that's the x value, what if I wanted it, get ready for the eye roll, Chloe, as a coordinate?
Negative.
Don't guess. What, could you just tell me what to do? If I wanted a coordinate, if I wanted the y coordinate when I know the x coordinate, what do I do? What?
It's only those lines. Your math backwards.
Well, you could do your math backwards and work that out. It's a little more work that way.
I should just look and like.
Well, if you wanted to guess, you could look. What did I do here? If I wanted it, if I had an x value and I wanted to know the y value, what did I do? But I have the x value and I want to know the y value again. I just plug it into the equation. Okay? So if I wanted the coordinate, I would just use.
I'm confused, isn't it? Negative 0.5 and then negative 2.
No, it's going to be slightly lower. It should come down like this a little bit. So it's going to be just below negative 0.2. So what you would do is you would take negative 0.5 and plug it into here. You get your coordinate. Negative 0.5 squared. .25. It's going to be when you work it all out. Okay? The coordinates? The coordinates for the vertex here would be negative 0.05 and negative 2.25. Yeah, that's my coordinates for my vertex. Okay? So right about now, in a perfect world, you guys should feel a little confused, but kind of understand what's going on. Okay, I can live with that. Now let's talk domain and range. Okay, so my domain is all my x values, right? And my range is my y values.
So you just write them all out.
No, don't write them all out. Technically, remember, with these arrows on, means the graph goes on forever, right? So it just doesn't stop. So if you wanted to keep writing, I'll come back in 20 years and check on you, Chloe. But you might be sick of what you're doing. Then you'll really hate math. Okay? So we just shorthand it. And we shorthand it like this. For domain, it's always, you put the D first and an equal sign.
Mrs. Menzies, 101. Mrs. Menzies, 101.
And then squiggly bracket. Do you guys remember doing this?
This stuff is easy.
It doesn't change. The domain is always the same. X, you put a line.
It's all really
There you go. That's the same. The domain is the same every time.
But don't we have to put something, a number into the X?
No, because X goes on to this. Is means X. The domain is X such that X is an element of the real numbers. A real number is any number you can think of.
So then why would we even have to put that?
Because you just got to do it. It just gets you used to doing it. In the higher up maths, when you start doing more of it, it's you thank me because you did it now. It makes it easier. All right. But my range, oh Lord, my range. This is where it gets wild.
It's a Y.
Yeah, it's Y, very good. Such that we put the line down again. Right. Y. If we look at, that's my smallest Y value. Right? Does it go below negative 2.25? No. So Y is going to be greater than or equal to 2.25. Oh, I don't make you do any like crazy formulas here or anything. You just got to write this.
Will there be a situation where like you have to prove if it's a
Parabola?
parabola, like, and if it isn't one, then would you have to find it?
No. Whenever you're dealing with domain and range here, I wouldn't mess it up for you like that. I'll strictly just ask you to write the domain and range here. Okay, domain is always the same. That's an easy mark on the test because that won't change. The range you got to be careful of. Right, if it's this way, if it's a minimum, y is always going to be greater than or equal to the vertex. If it opens downwards, though, you have a maximum. So that means y would be less than or equal to it. And everything will be smaller than the vertex, right? Okay. Any questions? All right. You guys want to try one on your own? No. Probably around 10 o'clock. I asked him to call at 10, but he's like, I'll see what I can do. People are the worst. Okay, on page 369. 3, 4, 5. Two, 3, 4, 5. All right. Make sure you guys are doing your homework because this is by far the hardest unit, of course.
Doesn't seem like that.
It's really not, but most people struggle with this because I don't know. They don't. No one does the work. If you put the time in to do the work, this is very straightforward. Okay. The more you guys understand this basic stuff of just like where the x's and the y-intercepts are in the vertex and how the graph opens up or down, it makes your life a heck of a lot easier. Okay. All right. So that's all I got.
Are you not?